okay now?
Yeah.
Looks good.
Yeah.
Given your choice, I'd be looking for that one.
Well, hello everyone.
Hello.
Hello.
A few weeks ago, Terry Fletcher asked me if I'd be willing to do a pitch down at OzarkCon coming up here first weekend in April. And I said, sure, you know, and what would you like to talk about? Well, I figured the EZkeyer, which I'm doing for the 4th Day QRP Club, would be a nice topic. It would be very appropriate. So I decided to go in to talk to some of the things about what went into making that EZkeyer that we sell as part of the 4th Day Club. So, basically what we're doing today is a dry run, hopefully, for timing type things to see how long it takes and what I should cut down and what I should change to make it more understandable. So I'll be looking for your feedback as to what things made sense, what things I need to beef up more, what I'm missing. So we'll talk about that. So basically we're going to have an introduction. We'll talk about microcontrollers in general, how we got into this whole thing. The pickle board, I'm going to show you why I use the pickle board as a basis for the start of this. That's a board that I made a long time ago, and we'll talk about that. Then we'll talk about the beginnings. I have 3 different models now. The first is the normal EZkeyer. Then I came out with EZkeyer 2, which I have here with the enclosure. And then we have the new one that I passed around the board for. I don't have the case done yet. It's still in China getting built, but with the speed pod on it. So, introduction. You probably all know me, Craig Jensen, and I originally was licensed back in the 60s. My call is WA0JVP. Larry was one of my high school buddies. He was WA0EDM, so E before J, so he was a year or so before I got my license back in the 60s. And we used to go back and forth in the same town here. And John is from Grand Rapids too, as it turns out, so yeah. So anyway, that's where we got our start. And I was out of it for many years until my kids came along in 1995. My kids said, what's this about amateur radio? And I said, okay, let's do it together. I'll teach the theory, we'll get licensed together, we'll go from there. And that's what happened. So the kids all got licensed. In fact, my whole family is all licensed now, but none of them use it anymore. We just went through the theory, wanted to get familiar with it, and then I kept going. So, and I have a lot of fun. Part of the thing that really made it interesting because I could see how much had changed through the years. And with the advent of microcontrollers now, I could see how controllers could be used to overlap with all the things we worked at amateur radio before. Another friend of ours and one of the founders of this club way back in the 1990s, Bruce Stowe, I don't know if you remember him, AA0ED. Bruce was one of the instigators of this club, and he and I were taking apart some of the code that was presented as part of a DDS project in QEX magazine. And part of that was to look at really deeply into the code of this little PIC processor, and we got really excited because you could see, man, this is really easy to control things really nicely. And we ended up, it was done by, this project was done by a guy in Rochester, Minnesota, and he ended up sending me all the files and everything for his board, and that's how I got going on the PC board maker that I still use right now for all these boards. It's called WinBoard. It's not made anymore, but I have all the libraries made in it, so I can't switch out of it because I'd have to start over, and it does the things I needed to do just fine. Anyway, we found a couple bugs in this code, things that the guy had been working on for years and never figured out how to do it, and Bruce and I pulled a couple bugs out and made a new version. So that was kind of the start of it, but it was exciting to see how microcontrollers were overlapping with amateur radio. So, from then on, the next step was to make this little pickle board. Now, this was a brainchild kind of the New Jersey club of George Heron. George Heron out in New Jersey club asked me if I'd be interested in making a little board to help people learn how to use microcontrollers. And then there was a course that went along with it with another friend that did. So we had a board a course that went along, and as people got to a certain lesson, they could flip over and try it on their pickle board and flip switches and everything. We'll talk about that a little bit too. Here's a picture of it. This is the 3rd version of it, and you can see, whoops, you can see down here there's lights that you can use to activate. This section of it is the programmer section, and this part is the demonstration part of it. So you have LEDs to play with. you dump the code in there and you flip the switch and that activates the rest of it. Of course, the PIC goes in there. There's an encoder here to change the frequency or whatever you want to do with it. A nice little 2x16 LCD. And then there's a section here for a daughter card to flip in. And we were putting a DDS daughter card here. That's what this is, the DDS60 daughter card. We call it a signal generator out of it. But it was a nice little board for teaching people how to write code for a microcontroller. And it was a really nice demonstration program. We sold a lot of these through Canada. There's still people asking for them. This is basically the circuit diagram for a pickle board. It's got two sections. As I was saying, the left side is all the programmer section. The right side is all the I'm going to wait here a second. It's really a clone of the PIC-Kit 2. If you're familiar with microchip stuff, PIC-Kit 2 was out a couple of years. They have a PIC-Kit 3 now. But the PIC-Kit 2 was a simplified clone of that version of it, so you didn't have to go buy the whole PIC-Kit. I was a little worried about it because it's published on the internet, a lot of the different designs and where people had simplified it. And I took one and modified it a little bit more to make my own liking. And I was a little bit worried about saying, because we're using the code that the microchip publishes to go in this PIC right here. To go into this PIC. They actually publish it, they could dump it into this thing, and then it runs like a PIC-Kit 2. I was a little bit worried about that. Well, a couple of years ago at Dayton, as I was sitting there demonstrating this thing, a guy came up to me and he handed me his card from Microchip, and he says, "Oh, by the way, I'm the guy that designed the PIC-Kit 2. Welcome to it." He said, "I love what you're doing." Steve Bible, his name is. He's real active in HAM. He works in the AMSAT organization. He's one of the instigators of the AMSAT organization. And he was saying, "Hey, you're promoting PICs. You're getting people to use them. More power to you. Go for it." Not like I was cutting into his business or anything. Anyway, it was only fun to talk to him about it, but he saw that I have a clone kind of part of his PIC-Kit 2 on the front end, just enough circuitry to get it going. It's not a big, robust thing that will work for every situation like his does, but it's enough. The other half of the course is this is a little bit more detail on it. The other half is the demonstration part of it, where you can try all the different parts, try all the different functions that are typically appropriate for hams. And so we'll talk about it. The center of it, of course, is I have a little processor, 628 in this case, but you can put any of the 18 pins in there virtually. And so what I'm showing you, okay, this is how I built the first keyer out of this. Okay, it has all the components on this board to make a nice little keyer application. So it takes the processor, a crystal with the two capacitors to make it active. The paddle input comes into two of the interfaces in the PIC. It's got a little speaker coming out of it with a little driver. It pulses the current on and off to make the speaker go. It's got a transmitter output, so you can key that. You key the transistor, that's like a switch, and it turns the transmitter on and off. So that was the hardware, and then I'll very quickly go through building it up again, the parts. These are the parts that it takes to make it. They were in the PIC-Kit 2, or the pickle board. There it is complete. Now, I made a little application for it. K1EL, if you're familiar with him, Steve Elliott, he sells a nice little keyer and a bunch of other keyboards and things like that. But he published an early version of his keyer code, and that was a nice example for me to look at to get some ideas. I talked to him about it, using it for other modified versions and everything, and whether I could modify a version to distribute with the PIC-Kit pickle. And he said, "Go for it. You know, that's what it's there for you to get ideas." So we did, and we made a nice little application that ran on the pickle board, modified it so it used the ports and the pins that I have on the pickle board. So that was a nice little start for a keyer for the pickle board. So now, the keyer, the EZkeyer itself. Back in 2009, Terry Fletcher, the head of the four-state QRP club, asked me if I'd be willing to make a little keyer as a fundraiser for the Ozark Con, which we're talking about coming up here first weekend of April. And I always kind of wanted to do a keyer, a full-fledged one in a standalone case and everything, so I said, sure, it'd be fun to try to come up with something that we could sell as a fundraiser for the club. So in the next few months, I made a board and did the code for it. Now, in that case, the board was very, very simple, just a couple push buttons and a couple of jacks. It still isn't very complicated, but it has added a little bit more circuitry with the latest version. But that one is very simple. So most of the most of the complicated nature was all in the code. And that's the one piece of code so far that I haven't released to the public because we're still kind of protecting it for the fundraising aspects of it for the club. So eventually we'll do that. We'll shove it out there. But right now we're still kind of protecting it so people don't just take the code and make their own little platform for it and run it. Just to help them sell it for a while longer. So, okay, how did we make the, this is started off with the pickle board, and how do we modify that into what we came out in the first year? First of all, the crystal, I got rid of that. I ran with an internal clock in the pick. I got rid of the push button on it. I'm trying to get down to minimal components, right? Not the things that were left on the pickle board anyway. Changed the battery from 5 volts, okay, from a 12 volt to a 5 volt, and hooked it in there directly. I simplified the speaker circuit. Instead of driving a transistor to switch it, I just ran it right to the speaker through a resistor, and then I got rid of the resistor. So it's about as simple as you can get. I turn on and off the pin. That shoves current to the speaker. You turn it on and off, and it makes a tone. Very, very simple, but and for the application that we're talking about, it works just fine. So we got rid of a whole lot of circuitry. They don't have to put on the first little key board. Then the transmitter, virtually the same. I went to a BS170 instead, a little MOSFET, a simple little one, very robust. And then there's 3 push buttons, and you notice these. What I'm saying down here is these can be configured as interrupt on change. One of the big things is I couldn't do on the pickle board is I couldn't make the thing go to sleep. You always had it plugged into power anyway, so it didn't really matter. But this one I wanted to run on a battery, and I wanted it to sleep all the times when you're not using it. And I wanted it to, so when you push a button, it would wake the thing up, it would do its function, and go back to sleep again. These are the 4 pins that you can use. You have to connect it to these 4 pins if you want to use those functions. So obviously I had to move things around. I wanted to still get 3 push buttons, okay? So I did 3 push buttons in this fashion, with the third one actually being the combination of the other 2 together with a couple of diodes. Push button 1 does the top one, push button 2 does the bottom one, and push button 3 will activate both of them simultaneously by pulling through a diode. And you have to do a little software checking then to say, you know, are both of them pushed at the same time? Then it's push button 3. And that's just used to activate a message, so there's not a lot of heavy-duty usage of it. Like push button 1 is used a lot more often. But anyway, that way I was able to get 3 push buttons on 2 pins, because obviously I had to have the other 2 pins for the 2 paddles, okay? So there's the 4 paddles, 4 pins used up, and I was able to get all the function I need to wake the thing up. You push the paddle, and it wakes it up and does the da-da-da, or you push a push button, and it'll wake it up. I changed the master clear to general I/O, so I got rid of the master clear button, so there's no push button on it. And then I added one more MOSFET on the output of it. Terry asked me to make a mute output on it. The mute output is something that I really didn't think I would use, but he said there are enough people that make simple little rigs that want this. Basically what happens is when you key a DA, it activates the mute 7 milliseconds before it actually transmits to or activates the keyer MOSFET. And then at the end, it'll hang on to the mute 7 milliseconds after the keyer is released. And what this does, it gets rid of thumps. It's a little TR mechanism for people that are trying to transmit and they don't want to hear that thump in their ears with very simplified circuitry. Now my thought always was to put that in the rig. That belongs in the rig, but he said there are enough people with standalone transmitters and receivers would like that function. So we put it in there and changed the keyer code to do that. I did some circuit analysis of the timing waveforms to see how much it really distorted the pure mathematics of it. And it was a little bit. Percentage-wise, especially more, 7 milliseconds is a bigger hunk of it when you go at 55 words a minute. But it's not too bad at the lower normal speed, so it's hardly noticeable. So it is there. It's available for those that want to use it. So there we have the first version of the keyer. Very, very simple, very little circuitry, and that's all it's up. Software. Now, this was the heart of it. I'm just going to go through a little basics of it, and I hope I don't frustrate you here. There are 50 elements, the vertical lines. Okay, the word pairs. The word pairs is often used as the timing element for an example to get things going, okay? And you notice the blue are the did-da, and so on, okay? Those are the typical spacing. If you talk, each one of these are equal element, equal length times the little vertical bars. So each of those the word pairs, those are the dits and the das. The yellow ones are the spaces between, inside the characters. The green ones are between characters. And the red, obviously, that's the inter-word spacing. So if you take all this and put it together, you get 50 elements for one word. Okay, that's very basic timing that a lot of keyers use to figure out what the element should be. So then at 5 words a minute, 250 elements per minute, 240 milliseconds. Each one of those little things has to be 240 milliseconds if you're going 5 words a minute. If you're going 25, then you're down to 48 milliseconds per element, and so on. So with a 16F628 processor, and I run it with a 4 megahertz clock, 4 clocks per instruction, so you get 1 million instructions per second, 1 microsecond per instruction. So it's very easy to go from there and make my timing loops and figure out exactly how many instructions I have to do to get 200 millisecond element and so on. And 600 hertz tone, I chose 600 hertz and I didn't make that variable because that's part of my timing algorithm, as I'll show you in a minute. And I had to make that very rigid because it's part of the internal structure. If I would have changed that, I would have taken all kinds of more complicated code in the keyer, and I chose just to make it fixed at one frequency. So it goes high for 833 microseconds and low for 833 microseconds. Obviously, it takes several of those to get one dit or one dot. That's why you hear a tone for a certain length. Now, I'm just going to give you a little piece of my code. I won't bore you with a lot of it, but I'm just going to show you the basics for how it works. Start out with a constant where I know based on what speed you've got it set to. I'll change a constant in my code, and from then on I can use that so I can pick it up in the code. I say, what speed are we running at? Oh, that's the number of loops I have to make a dit at that speed, or a dot at that speed. And then here's the basic loop, okay, that I'm doing for making, this is one dit delay, okay, one dit. And so I have a little thing to, this starts out with it unkeyed, and then the second half is keyed. So it looks backwards, but it works fine. And so basically I'm taking it for a half period, and I'm going back and forth for this length time. And then finally I turn the tone on, and then I do the similar loop. Okay, and then I go back to the top again. So it does that over and over again. That makes it 600 microseconds, and you loop the whole thing for a certain length, a certain number of loops, and that makes your dit for the right length at 600 hertz. Okay, so it looks more complicated, but it took a while, but it's not too bad an algorithm. Now, if you want to turn the side tone off, I have basically the same timing, the same parts of it, but I just have a bigger loop, and I don't turn the tone on and off in that part of it. So I just flip it. See, I have no option there instead of doing all the checks before. So that was very simple. So what we have is a 12 direct entry from the panel commands, 3 messages, 31 characters each, 5 to 55 words a minute, which should cover things. I have a ARB, straight key, or coding modes. Coding mode is where you do the DAS, or dits or DAS by using the paddles. You know, you punch it like a straight key on each side. Sequence midline, we talked about that. Default speed and all those things are stored at double EEPROM, so you don't have to worry about them over power loss. They're all saved. Speed is entered by command or changed on the fly by the paddles. You can either key in how many words per minute you want to go, or you can press the command button and hit the dit or DA to go up and down 2 words a minute at a time. And so that was very, for me, I didn't need a speed pot, but a lot of people like them, so we ended up changing the next version. But this was very sufficient for me for changing the speed up and down very quickly, and I always knew where I was. So at very low power, you don't even need an on-off switch because the thing goes to sleep when you're not either pushing the button or activating the paddles.
Looks like a leap into the future, April 4th.
That's when Ozark dies. This is set up for Ozark time coming up. I didn't want to change it all. I'm going to do it once. Yeah, you can report the speed. You can operates 3 to 5 volts, 600 hertz. Turn it off if you want to. Auto spacing, if you want to use it, it'll help you make perfect spacing in your code. Some people like that. I think it frustrates me more than it helps me. Paddle swap, you can go back and forth, the key line, and so on. And mounts in an Altoid skin. So this is the first prototype board I did for that. Pretty ugly. I had all the basic functions, and I could get all the timing done and all the software for it. This is what the little board looked like. You've all seen that next to a quarter. There's where it's built. There's where it fits into an Altoids can. And there's Terry Fletcher did the artwork for this little EZkeyer outside, the decals and everything. He actually built this one to give to me for doing the work for the first one. So that was the first version. Now, EZkeyer 2. First of all, one of the things I needed to do was change it from a 628 to 648, just because it's got double the memory. There was a no-brainer other than that. And that allowed me to get more message length. Okay, I went from 31 up to 47, 47, and 79. People like to make big, long messages for some reason. I thought 31 is sufficient, but they like longer ones, so we were able to accommodate without too much change in price, actually. 648 is not too much more than the 628. I also have a bug emulate mode. One of the guys in Ozark County last year says, I won't have any keyer in my shack that won't emulate a bug as well, because I want to stay current with how to use a bug. I thought, okay, I understand. I'll give you a bug emulate one. So I was able to work it into the code and some of the algorithms. So now the DAWs are manual on one side, and the DITs are automatic on the other side, and it works fine. So bug emulate is one of the menu selections you can do now. And the enclosure made from PC boards soldered together. So we just passed this around, but I won't probably have it at the conference, so I want to show how that works. Basically, you broke off all the parts. There's the layers in the back. You put a little blob of solder in the middle. You line it up like that with little notches. You heat it up, and it'll hold that side. Do the other side. Do the end. Got a nice little box. Then you go back and reinforce it. And when you get it done, then it changes color to blue instead. No. The first one was my prototype green, and this is the final version of that. It really worked nice. We're getting lots of sales, and people are really like the fact that it's a built-in case. The case, by the way, cost me $7 from the pre-sequence manufacturer. My bare boards, we lumped it into the whole package. But it wasn't very expensive, and then they have all the drilled holes and everything, plus the silkscreen instructions and everything, and the labels on it. Man, talk about with it. I'm going to use that technique. I actually learned about this, by the way. Last year at Ozark Con, we were just chatting about that. They built the Cyclone 40 with this kind of a technique. Dave NM0S built his little Cyclone 40 with a box soldered together like this, and I said, that is neat. So I switched to his company in China to build the boards, and I went through and I figured out how to make the box like this. So this is thanks to Dave for that design technique for making boxes like this. We're going to use that again, by the way, for the future. There's where it fits in the hand. You just see kind of a relative size. But now EZkeyer 3. They kept saying that I kept asking what's the biggest drawback. What do customers ask for most? And they all said the speed pot. I said, speed pot? You got to be kidding me. Why? Because Electronic does it. A lot of the other keyers all have a speed pot.
Wayne did it.
Wayne did it. Well, so, and I said, well, okay, well, let me see what I can do. But I knew that I didn't have, first of all, I didn't have a A to D converter in it, okay? So I'm going to have to figure out something. And part of it, if it's going to be voltage dependent and I'm running with 5 volts, I can't do that anymore because the battery sags a little bit, it'll change the speed. So I ended up having to change the speed, change the voltage mechanism to a 9-volt battery with the regulator on the board now. A little more complicated, a little more circuitry, but I could know that I was always going to be at 5 volts. Yes?
What did the cost of the pot do to the kit? Would you end up coming up with?
Not too much. We'll talk about that. We're still getting the final pricing for it. But it just added a couple bucks, and the regulator's a couple bucks, and there's a few other parts, and there's capacitors around the regulator and things like that. So, and the shim, and there's a few parts, but it wasn't too bad. So, and I actually I'm going to use 2 batteries. Yes.
Do you look at a rotary encoder for that function also?
No, I don't want to do that yet because then I'd have to. Then you don't know where you are. Okay, this I can turn it on. I know where I am. A rotary encoder, you wouldn't. It's all relative then. Okay. So, but I'm going to hook it up with 2 sets of batteries if you want to, just to get, they're all in parallel, not voltage, okay, they're in parallel so you get added battery life without having to open the case up. 1 battery or 2 batteries, either one, you can take your choice and hook them up. And it works out nicely. For pretty good battery life, not quite as good as the one we had before with the with the 4 AA's, but 9 volts are pretty decent when you get 2 of them in this kind of battery. Then I'm making a modified enclosure. Now, I don't have the closure done yet, so I can't show it to you, but I won't talk about that. One of the things that I had to do was calculate the dit and the dah speed based on this speed pot on every dit and dah. In other words, in the middle of a message, you could be changing the pot and changing the speed. And it'll pick it up, it doesn't do it, it's just the beginning to the end. It'll do it anytime you want to change the speed pot, it'll adjust it. So at the beginning of every dit and dah, I've calculated it, I'll show you how, and adjusting the length of that dit or dah based on where the speed pot is. No analog to digital converter, analog to digital converter on the 648 that I'm using, so I had to do, I'm implementing what they call a poor man's A to D converter. And I'll show you how I do that. It's a published technique, I guess, but I kind of figured out for my own, and then I went back and looked, and there were some other examples of how people have done this. So I'm going to morph it here. I'm going to show you the changes that I had to do when I went to the keyer 3. First of all, I put the voltage regulator out there. I moving it a little bit. Put the capacitors around it. I changed the speaker, so now the speaker is coming right off the 9-volt line, 9 to 12 volt. It's to get a little more volume out of the thing. For people like Mert that always complain that it wasn't loud enough. No, but this allows me to put the full 9 volt through a little switch. The BS170 again is a MOSFET switch to run through the speaker, and then with a volume control on it. So I have a little inside of it. I have a little volume control. That's not going to be on the outside of the case, but you can adjust it once for however loud you want it. So, and then I found out I had to put a resistor across the speaker and piezo. I don't know if you guys are familiar with how those things work. They look like a capacitor otherwise. And you charge it up once, and then you hear one dip, and then it doesn't go anymore. But you put a resistor to let it discharge itself, and then it works fine. So that was a little monkeying around, but really simple to do, and it works fine. Now, we have a little electrical lesson. Okay, if I come out of the top there with 5 volts, go through a 220 ohm resistor, how much current is going to flow through there? 5 volts, 220 ohms, right? 5 over 220 is 23 milliamps, okay? Is that right? Now, if I put a switch here, okay? You see up the top there? If I have a switch and I open it and close it, okay? I'm going to run 23 milliamps, okay, into the capacitor, and that's going to eventually stop. But if I flip that switch, then that whole 23 milliamps is going to go to ground, right? And the capacitor will discharge to ground. So as soon as I open it up again, it's going to start charging 23 milliamps. It's going to go into the capacitor, right? So now what's it going to look like? Well, that's hard to see, isn't it? You can see the line here, the normal capacitor. This is where I hold it down with the pick, and then I release it, and it's going to take a capacitor charge cycle like that. That's what it's going to look like. Now, from electrical theory, the tau equals RC. A tau is a time constant. So typically, what a capacitor will do is it will go up, it'll reach 63.2% of its full value in 1 tau. And then you go another tau, and go up another 63% of that. So in this case, with I'll have to show you. I have a pot that I added in here. I put a pot in there that's where the adjustment's going to go. Okay, I'll have to change that order. But anyway, because of that, the 1220 ohms in with the size capacitor that I use there, 68.068. That's the length of time it takes, 83 microseconds to get 1 tau. And as it turns out, 1 tau is about the right spot for switching. So all I had to do is hook it up to a PIC pin, okay, that's here. So I could switch it on and off with a PIC pin, and I got the same circuit we had before. It looked like I had a switch on there. Well, now the PIC is doing that. So he can jam it down and then release it and watch as that capacitor charges. That's the poor man's A to D converter. So what does it look like? There's where the resistance is at is low resistance, okay, so it'll charge very fast, and you can see it going up almost instantaneously, very, very fast. It's not instantaneous, but fast. And then we saw the slow one. Now, and then I use a lookup table to convert the number of loops to speed. I'll show you how that works. See these little vertical lines? In my code, for debugging purposes, I put a little tick counter, I tick another pin so I can watch it. I turn it on and off as part of my loop, and every time I go through the loop, I'll tick that thing on and off one time. So then I can take a picture of this thing, and I can expand it out, and I can count how many ticks there are, and that'll tell me how many times I went through my loop. And this thing jams it low, and then watches as the voltage rises, and watches when it changes from a 0 to a 1 on the input. So when it gets to a certain voltage level, which is right there, it's going to stop my loop count, and it says, I reached it, okay? And all I have to do is know how many times, how many loop counts I have, and that's how I can adjust the speed. So, right there is the transition point. It turns out it's about 3 volts, 2.8 to 3 typically when you're running at 5 volts. So that's when it stopped my loop counter, and then I can get ready to key the transmitter. Now, back to this one again, when I have it at a minimum resistance, you can see I only had 2 loops. I'm going to expand that out. Two times through my loop is all it took to charge the capacitor to 68 to 3 volts and stop it. So then I can quickly detect. So all I have to do is say, if I got 2 loops, I know I'm at the minimum. If I got 68, actually it turned out to be about 87 at the very maximum to get to the other end of it. So I expanded that just to see the individual loops a little bit better. 89. And now, how long does it take to go from doing all the calculations, look it up in the tables and everything else, to key the transmitter? Well, the red line is keying the transmitter, okay? So this is where I detected it, and it took that much time to key the transmitter. 70 microseconds. 70 milliseconds. No, that's wrong. 70 microseconds. So it's a total of 600 microseconds it takes to do the calculation at the beginning of every dit and dot. So then I did some quick calculations to say if at 5 words a minute, 240, 620 microseconds is just minuscule. It's a half a millisecond, 0.28% change at 5 words a minute. It's a little bit more. It's a bigger percentage, of course, than at 55 words a minute, 21 milliseconds. So it's 2.8% of that. But once again, you can't even detect it. So this is a very clean little mechanism, as it turns out. It just adds a little bit of length at the beginning of every dit and every dah, but it didn't really, wasn't enough to affect the timing. Next thing I want to do is add what I call some lookup table, some speed limits. There are 2 little jumpers on there. One of them allows you to, well, if you leave both the jumpers off, you get the full range. You move the pot from one end to the other, you go from 5 to 55 words a minute. If you're like me, that are never going to go 55 words a minute on a bet, I had to test this thing to see if it really going 55, and I had to key in some commands and read back what the speed it was at 55. That was a challenge. It took me a little while to get that. But it was there, I could read it at 55. Yep, that's what it's doing. Anyway, so I can put a jumper on there, and I'm gonna wipe off the top end, so now it's drop the top end down to 34. And then if you are like me that never want to go 5 words a minute, if you want to go with Farnsworth or whatever, if you really want to go slow, I made the other end 15. So you put both jumpers on there, and now it goes to the mid-range 15 to 34. It doesn't, you move the pot full way, and it'll go 15 to 34. You don't have to worry about, you have a little bit more, little fine tuning, which made it a good advantage. By the way, I haven't seen that in any other keyers that have done that, but it worked. So there's the 2 jumpers at the bottom here. I just hook into 2 pins, and I look for that when I run.
Just checking for a digital on-off.
Digital on and off. That says if the jumper's there or not, and that says go to a different table. I have a different lookup table in the code then to see what the number of loops correspond to words per minute.
So those are jumpers inside the box?
There's the jumpers on the board inside the box, right? Yeah, so you change it one time because people usually know if they're ever get to that speed or not. I know I will. So there's the prototype board. We passed that picture around. A slightly larger PC board. These are the 2 little ears that you break off. It goes under the, it goes in the spot right in the middle here. Okay, and there's 4 wires in the 4 corners. They're going to go drop all through, and you solder at the top and the bottom, and then the pot goes into that top little shim and fits down into that little window. But it's real easy to solder, and it goes together real nice, and then it gets up to the right height, so it's the same as the push buttons And so the cover goes on with the same number of threads. There's the board that we passed around. Linear logic case. You can see, it's hard to tell here. This is the best I have, but this is the version that's being built right now. It's slightly shorter, but it's slightly thicker. And then the speaker is going to be down on the end of it, down facing you, because it'll fit up on the end, and I was able to make it shorter when I did that. So the speed pod is going to be right in the middle, and the 3 push buttons. There's the internal speaker is going to be behind that little hole, but otherwise it'll face you in the front. And the paddles and everything are out the back end, just like those before. So, and I added one key, command in here, the P. P is going to toggle it back and forth between speed pod, or if you want to use the paddles again, you can still do that. So there's the speed pod on it.
How difficult, Craig, was it to code for when people want to input a command,
Yeah,
and you're actually having to read someone's code, good or bad?
yeah.
How hard was it to figure out, is that a P, is that a C, is that a
Yeah,
whatever? in
I
digital
do it elements at a time. I mean, you can change all these commands, they're all the same thing, right? But I have a reader in there that takes one thing at a time and puts them together and says, is that a legal character or is it not? Is it in my lookup table or not? And I give them a reject if it's not, or if I say that's a good key in and do whatever it is.
Any feel for what percentage of accuracy?
I don't
person
even do
needs
that.
to
They don't
get?
have to do it at full speed. You can key in a W by going dit, da, da. Yeah, we're saying it's dit, da, da. Just because of the way I implement it. A lot of them don't do that. But then that makes it really interesting, make it really simple if you really want to put something at fast speed. You just getting dit, da, da at 55 is tough enough with my simple little paddles because they're so short. I'm going did it all the time. Every time you go did it, then it would change the iambic mode. So. Okay, so now I'm going to switch gears a little bit for a wrap up here. And I know a lot of this was gobbledygook and maybe not interesting to you, but maybe some people found it interesting. But I like to switch gears a little bit because this is something that's important, I think, and it's something to take home with you. A couple of years ago, I was working for a company that is on the outside of town over in Plymouth, and I had about a half-hour commute each way. And because of that, I wanted to have something to do, make up my, it was actually 40 minutes, depending on the weather, a little bit longer. I could put a rig in my car, a 2-meter, and talk to people. But I chose to do another little different way, and I got an Amazon Kindle, okay? And I figured out a neat little way to rig it up on my steering wheel with some duct tape and some wires so I could read when I'm going. No, I didn't do that. But someone else thought of a nice way. Look at that. This was just this last week I found this picture. Somebody has a way of putting their iPad, their phone up on their steering wheel so they can read text while they're going down the road. Highly illegal. I don't know how they do this, but you can get it for $12.
Wouldn't that be illegal?
I think it is. But anyway, what I'm saying is,
Only if the phone is turned on, right?
Well, no different.
I don't like that. Okay, my Kindle has a text-to-speech feature, okay? So I can put it on the seat beside me and it'll read the books to me, okay? And with this feature, I was able to go through all kinds of really good books, okay? I went through books on politics, I went through economics, I went through things on theology and apologetics, some of the heroes of the faith from C.S. Lewis and some of these people that I really enjoyed reading. I went through all kinds of very interesting books like that.
While you're driving, you mean?
While I was driving, I could listen to the book.
Audiobooks
Like
are
audio
wonderful
to
in the
tape.
car.
Yep. And it was fascinating, the good books. A lot of them were free. And I read some really interesting biographies of some of the forefathers, Benjamin Franklin, free books, all this. And then I came across a free one, Thomas Edison. And Thomas Edison was one of the people that was so fascinating because, first of all, he's home educated, self-educated, never went to college, and his mother pulled him out of school because kids were making fun of him. This is one of the things that was really inspiring to me, and I'll show you why in just a minute. Self-educated, okay? Excellent CW operator. When he was a real young kid, he learned CW. And he used to get jobs with the railroad and everything else, doing CW. He could easily go 40 to 50 words a minute. And listen, folks, he didn't have a typewriter, or a computer to type it into. So he had to write it by hand. And this is the telegraphs going across the country, and they're sending messages. Somebody else has got to read what they write down at 30 to 40 words a minute. and read it and transcribe it and say, yes, this is really what it was. And he could do that with ease, okay? He was actually in the telegraph office the day Lincoln was shot. He passed that message back and forth in this is the late 1860 approximately.
1865.
Yeah, okay. But the things that he was doing, he's working in the telegraph office the whole time. That was kind of the heyday of his experiments in the 1860s. Anyway, he was a fantastic CW operator. He experimented a lot with wireless, even though he doesn't get credit for it. You don't hear about it. But he was playing with some of the same circuits and things that Hertz was and some of these other forefathers in the wireless field. They just weren't interesting enough to him, and he just chose to look at other things instead. Extreme patience. Now, this is the kind of thing that I want to get to you. Thomas Edison, you might say he was a big brainy guy, everything just came to him, and he just, you know, things fell into his lap. Folks, it didn't happen. This guy worked hard, okay? The reason he got what he did is because he worked so hard at it. One of the experiments that he was talking about, his lab assistant said that we do record keeping on how the different experiments that we did. And we'd write it down in our lab book and we'd number it. We started numbering at number 1 and we'd start counting up. We'd count up until we got to 10,000. And then we'd start counting backwards again. And he said some of these things took us several cycles before we came up with the answer. Now I think about that. Say 50,000 experiments before he came up with the answer. How many of us are willing to work that hard on something that we want to experiment with? We give up, okay? We play with something for a while, he said, oh, leave that to somebody else that's smart. Thomas Edison just kept going, kept going, kept going. He didn't get tired of it, that's what I want to get across. Folks, when you get something that you're interested in, keep going, keep trying, yes?
Wasn't Thomas Edison who said invention is 1% inspiration, 99% perspiration?
That's right. So, the main thing is he was insistent on good record keeping, okay? When his labs, he had hundreds and thousands of, 4,000 I think, lab notebooks, okay? And how he could find stuff in his lab notebooks, I'll never know, because he didn't have any index method. He didn't have a computer to tell him which lab book to go to, but he could find them. And that's one of the things he insisted on, is keeping all these records, and that's what I'm trying to say to you guys. Write it down. As you're doing your experiments, keep a notebook. Write it down, keep track of what you're doing, keep track of what your experiments are, because you're going to forget it. Mert and I talk about that often, about how we have to go back and look at our notebooks when we're trying to figure out what we've done. And I saw this as an example of good engineering practice that Thomas Edison, way back there, was working with. So, the secret of achievement, hard work based on hard thinking, okay? So, that's what we all have to, as an example, I think that we can all take to heart of whatever we're working on. So, experiment with something that interests you. Find something that you feel like playing with. It doesn't have to be what somebody else is interested in. Find something that you're interested in and then dig into it, okay? Write it down in a notebook, okay? Keep good records, keep it so you can come back to it sometime later and figure out what you've done. And the next thing is don't give up, okay? Hang on, keep working on it. And this is a good place to come and share with people what you're doing, what you're finding, and people are interested in what you're experimenting with. It'll be different for everybody. There are, you know, antennas or rigs or whatever. But grab onto something and play with it, and you'll be surprised how it'll advance your own interest and experience. So that's basically, there's some references and stuff. We have a new, some key. But any questions after that? Yes?
I might have missed it, but when you're going through the speed,
Yep.
when it counts
Yep.
the cycles, do you have it set in your tables that the faster speeds are the fewer number of cycles, or vice versa?
I had it working both ways. I ended up in the final version, the fewest bits are the slowest speeds. Okay, I just about at the table which order you put the things in. It's just a lookup. You could do it either way. No one outside will even know, but you know, I had it the other way, and I thought it made more sense internally for me to think about it. With 2 cycles is the slowest speed, and 87 cycles is the fastest speed.
Well, kind of arguing the other way, thinking
Well,
less time to do your
right,
check
that's
for
sure,
higher
yeah.
speeds.
Yeah, I had it implemented both ways, and they said it didn't really matter, but no one outside will even know that.
What do you think is the schedule for the version 3 of the keyer?
I'd say within a month or so, I should be getting close.
Is the idea to have it up for?
I don't think I'm gonna be able to get it ready for that, for Ozark Con. But I'm pushing hard, I will. It depends on how this first version of the keyer, of the case goes, how close I am to the final version, and if things fit right. You know, that was the biggest problem before, it takes a while for cycles.
But is the goal to have it for Dayton?
No,
or-
and not really. I'm not even gonna be selling things at Dayton. So it's all through the website, through Four State Club, so I don't even know what.
Any feel for how many you've sold so far of each of those versions?
Yeah, let's see. Several hundred, I'd say. So, the 2 hasn't been out that long. We probably sold about 100 of those. We sold several hundred right off the bat of the first keyer, so something on that order. Not huge numbers, but you know, enough. And it's just kind of a steady rate now. We do 2 or 3 a week or something like that, so it just keeps going. And that's such low overhead and such low parts count that it doesn't cost much to keep it going. So we're hopeful that this is going to open up a new set of people that it appeals to, and maybe it'll last for a while yet. And we'll see how it goes.
An interesting observation, talking with other people that, like Craig or myself or Jason out in Oregon, that are looking at kitting or selling stuff, and you look at the barrier to entry and what do people request in kits, and Dave was like this when he had his business, Benson. The cases for these small kits are such a pain for folks to sit down and figure out how to machine these things. The kits that have some sort of an enclosure, either that you can buy or come with them, it's a revolutionary approach to a lot of these kits in accessibility for folks. I mean, it's a big change.
So,
Now that's, for even this thing here, the major design
yep.
issue is putting the box for it to go into.
So if you were going to explain that to somebody else to build them and just like it, you can imagine the grief it would be. Where do you get enough parts? Where do you get all these switches? Where do you get? How do you drill the holes?
How do you get it to a line? And
It's an
I
absolute
screwed up the
pain.
drilling.
And that was the biggest problem. We're still working on the AM project, by the way, Mert and I, okay? As part of that, I'm gonna have a case like this, okay? I've always done some prototypes where I'll have a case that I've got the little front panel with the LCD sticking out the front of it where the signal generator fits. I'm gonna have some internal shielding in there. You can just solder them in to go around the signal generator to keep it isolated from the rest of the circuitry, all that. We've got a prototype, rough one. But we're working on that. That'll all be part of the project, is to have a case for it, I'm sure. So, of some type.
Craig, are they still using their keyer on the balloon flags?
And the balloon flight, they still do them every now and then, and they still use the keyer. They used the very first one, and that didn't have the delay command. I don't know if you're familiar with the delay command. Right now, that you can put a D in there, a D key in, and that tells you a number of milliseconds to wait before repeating the message again. It's a number of half second delays, okay? So you can put 1 through 9. And if you put 0, then it turns it off. But you put a 9 in there, and then you key in any one of the messages, and after 4.5 seconds, it'll repeat it. And that's what they wanted. They were jamming it on with a wire jumper before, but this makes it real easy now. So anybody can do that. If you're doing a CQ and you want it to repeat, you can just put a number of milliseconds, a number of seconds between them, and put any value you want there. So yes, I think as far as I know, I saw not too long ago they had a balloon flight with one of these keys in it. So
I think they're having a hard time because helium is starting to become
very
very difficult to come by. So a lot of the balloons out of Iowa and Colorado are slowing down.
One is hydrogen. That's what I was going to say. Any other questions or?
Have they set a price on that?
No,
Number 3?
no. We still have to, I have to give them the final parts count, make sure that it all works first, and then we'll pick the price. But I don't think it's going to have to go up by too much. We had to raise the price between the 1 and the 2 because of the case. We had to go from 22 up to $30, I think, something like that, to cover all the costs of this stuff. And this one is going to probably add a few more bucks to it, but not too much. The case will be there, and we'll add this pot and the regulator and a few more parts. And there's another the voltage pot on there also. I don't know if you saw that. It's down the corner down here, and you can twist it and change the volume of the side door. So there's a couple extra parts in there, but then none of them are very expensive, so I'd say it's gonna be minimal change. Okay? Well, thanks, I really appreciate you. And see how long did that go? I don't even know.
You're good, 45 minutes.
Okay.
Thanks, Craig.
Yeah, you're welcome.
See everybody next month. Those not going to those are.
Resistor.